So solving rational equations. We have a couple different methods. Our first method is called cross multiplying. Have you heard of cross multiplying before? Excellent. So then that should be easy. But you can only use cross multiplying sometimes. You can only use cross multiplying, only use when you have one fraction equal to one fraction. So you have to check first. Example 1, do I have one fraction equals one fraction? Check. So you can cross multiply. If I just like go ahead to some other question, example 3, I just opened it up. You don't have to follow me there if you just look up here. Can I use cross multiplying for example 3? No, because I have two fractions being added equal to another fraction. If you have two fractions equal one fraction, you cannot use cross multiplying. So to use cross multiplying, see that bridge in between the two fractions? You see that bridge? Yeah, so you get to cross over the bridge. We always cross multiply up for whatever reason. Nah, I know what it is. I'm not going to talk about it though. And I'm going to have 3 multiplied by 4x plus 5 equals 9 multiplied by x plus 1. So notice that the binomials I kept in the parenthesis, because what am I going to have to do with that 3? Distribute. Excellent. So we'll go ahead and distribute. And I have 12x plus 15 equals, and I'll distribute the 9x plus 9. And now it's just an equation we should be able to solve. So subtract 9x from both sides. 3x plus 15 equals 9, and then subtract 15. 3x equals negative 6. Divide by 3, and we get x equals negative 2. We also have to check domain restrictions. I probably should have just done it from the start. I just keep forgetting because I've done this so long that I just do it automatically, but I forget to say it to you guys. So I'm going to go back and check the domain restrictions from the start. I have x plus 1. So if x plus 1 cannot equal 0, then x cannot equal negative 1. I also have 4x plus 5 cannot equal 0. So 4x cannot equal negative 5. So x cannot equal negative 5/4. I'm going to check those domain restrictions with the answer I got. So I got x equals negative 2. X is not allowed to equal negative 1, and it's not allowed to equal negative 5/4. Are we good? Let me say that again. I got x equals negative 2 for my answer. From the domain restrictions, it's not allowed to equal negative 1, but it's not. And it's not allowed to equal negative 5/4, and it's not. So this is the answer. So with domain restrictions for these kind, it's different because we're now solving. For domain restrictions with these kind, the answer can't be negative 1 or negative 5/4. My answer isn't those. So I just have x equals negative 2, and I'm good. I could also just check the answer by plugging in negative 2. So I could do 3 over negative 2 plus 1 equals 9 over, I plug it in, I get negative 8 plus 5. So I get 3 over negative 1, which is negative 3. On the other side, I get 9 over negative 3, which is negative 3. That checks. If my answer was negative 1, something that it wasn't allowed to be, when I went and checked it, it wouldn't check. Or if you made a mistake, it wouldn't check. Okay? So checking our answer is helpful because when we have equations, we can always make sure that we are correct or know that we're not. So you can check your answer. All right, so we got solve by cross multiplying. Go ahead and take a moment. Cross multiply. Practice, practice. I'll be around to check what you're doing. All right, so number 3, I cross multiplied. Then I'm going to distribute the x. And now I need to isolate x, but x has an x squared and an x. So when we have a situation like this is like the majority of the solving that we've done this year. We need to make it say equals 0. So I'm going to take away 11x and I'm going to take away 8 so that my 2x squared stays positive. So I get 2x squared minus 6x minus 8. When we have a quadratic equation, methods of solving could be factoring, quadratic formula, complete the square. I'm going to try factoring because I hope that it's factorable. Oh, there's a GCF. Ooh, that makes things easier. So GCF of 2. So then I'll have x squared minus 3x minus 4. So I'm going to factor and I will get x minus 4, x plus 1. And I set each factor equal to 0, x minus 4 equals 0, x plus 1 equals 0. I don't set 2 equal to 0 because that's not an answer. That's just a 2. So I get x equals 4 and x equals negative 1. I forgot to go and do my domain restrictions right away, so I'm going to go do those now. Go back up and look at those domain restrictions. 2x plus 5 does not equal 0. So 2x does not equal negative 5. So x does not equal negative 5 halves. Neither of my answers are negative 5 halves. And then I've got 11x plus 8 does not equal 0. So x does not equal negative 8 over 11. So these are my 2 domain restrictions. Neither of my answers are those domain restrictions. So since both of these answers work, we have 2 answers. Put them in order from least to greatest. Okay, now, as we were working on this, somebody said, well, what if the domain restriction is our answer? What if the domain restriction is our answer? Don't worry, we'll get there. That's coming up. So example 3, we now cannot use cross multiply. So we're going to use a different method that is multiply both sides of the equation by the lowest common denominator. This is multiply both sides of the equation by the lowest common denominator. So the first thing we need to figure out for example A is what is our LCD, our lowest common denominator. Hopefully we can look at it and figure it out. If not, then we'll have to factor and combine the common factors and add in the extra factors. What is the common factor, lowest common denominator for x, 4, and x? 4x. So I am going to multiply both sides by 4x. Okay, since we are multiplying fractions, I will make that 4x into a fraction over 1. So we multiply everything by 4x over 1. So I will have 20x over x plus 28x over 4 equals negative 36x over x. So I multiplied every part of it by 4x over 1. None of the denominators changed, only the numerators changed. Do you see? I'm allowed to do that because it's an equal sign. I'm not allowed to do that if we do anything that we were doing in the past. This I'm allowed to do because of the equal sign, as long as I do it to both sides. So from here, I'm going to go ahead and simplify 20x divided by x. Those x's cancel out, and I get 20. 28x divided by 4. The 4 and the 28 cancel, and we get 7x. Oh, I meant to put this in purple. And then on the other side, the x's cancel out, and we get negative 36. Now it's like a really easy Algebra 1 question. Let's solve for x. Take away 20. 7x equals negative 56 divided by 7. X equals negative 8. I'm going to go back up because, again, I keep forgetting my domain restrictions. X cannot equal 0 is my domain restriction. That's the only thing in the denominator. I got x equals negative 8, so I'm good. I can also check it by plugging in negative 8. So look at B. First thing we need to do is find the lowest common denominator. I'm going to stop talking for a second because I want you to find the lowest common denominator. I'm not saying the answer. To find the lowest common denominator, first thing you want to do is factor the denominators. How do I factor x minus 5? How do I factor x minus 5? Ella, do you know how to factor x minus 5? Factor. You're not answering the question I'm asking. Remember factoring? Where you like have a GCF or you write the 2 parentheses, that stuff. Can I factor x minus 5? You cannot. So when I say, how do I factor it? You say, you can't. Thank you. How can I factor x? Ryan, how can I factor x? I can't. Neither of them are factorable. So how do we find the greatest common factor? Sophie, how do I find the greatest, not the greatest common factor, the lowest common denominator? They don't have anything in common. So this would be like if I had a denominator of 2 and 5. What would I do for my denominator of 2 and 5? I would multiply them together, and that's what you were answering earlier, wasn't it? Yeah. So my LCD is x multiplied by x minus 5. So that's our LCD. We are going to multiply both sides of the equation by the LCD. So I'm going to multiply both sides by x times x minus 5, both sides. That is not a fraction, so I make it into a fraction. I put it over 1. And you see that 1 that I'm multiplying it by? That can be over 1 also. We can make everything look like fractions because we multiply fractions straight across. So straight across, I get x times x minus 5 over 1. Subtract 8x times x minus 5 over x minus 5 equals 3x times x minus 5 over x. So I multiplied all those numerators. The denominators just multiplied by 1, so they didn't change. Now we can look for things that cancel just in the individual fractions. And in the first fraction, nothing cancels. We don't have to write it over 1. The second fraction, the x minus 5s cancel. The third fraction, the x's cancel. All of your denominators should cancel out if you've done this correct. So now I have x times x minus 5 minus 8x equals x minus 5. We are solving an equation, so I will distribute. When I distribute, I notice there's an x squared in it, so I'm going to make it set. I'm going to set it equal to 0. Yes. It just went on a bathroom break for a moment. I don't know where it went. 3x minus 15. I should probably, let me write it how I had it before. Thank you, Ashlyn, for saving me some time of figuring out what I did wrong. There you go. Okay, so now I'm going to set it equal to 0. X squared minus, I'm going to subtract 3x from both sides. So I've got minus 5, minus 8, minus 3, so minus 16. And then plus 15 equals 0. I'm going to try to factor that. Hopefully it factors. X minus 15, and x minus 1. That works. So I get x equals 15, x equals 1. But I got to check my domain restrictions that I forgot to do at the beginning. X cannot equal 5, and x cannot equal 0. Does x equal 5 or 0? No, so we're good. We get that x equals 1, 15. Put them in order. Okay. There's 2 that you're going to try, and the third one you can try, but I'll end up doing with you, okay? 3 of them total. 2 of them you're totally trying. The third one we'll do together, unless you're working ahead. All right, so example 4, first thing we're going to do is find a lowest common denominator. Our denominators are x plus 3, x plus 3, x minus 3, and then x squared minus 9. If I factor x squared minus 9, I get x plus 3, x minus 3. So to make all 3 denominators exactly the same, then we need to have x plus 3 and x minus 3 in all 3 denominators. But this is a different kind. I don't have to say what's missing and give one of them this or one of them that. I just have to multiply everything by the lowest common denominator. So we're going to multiply both sides by x plus 3 times x minus 3. Both sides. So I will have 6 x plus 3 times x minus 3 over x minus 3 equals 8x squared times x plus 3 x minus 3 over x plus 3 x minus 3 minus 4x times x plus 3 x minus 3 over x plus 3. That should cancel out every single denominator. Oops. So now I have left 6x plus 3 equals 8x squared minus 4x times x minus 3. That middle step was a lot of writing, but you see what happens after I multiply all those parentheses. I don't have any fractions, and now it's something we can solve easily. Distribute. So 6x plus 18 equals 8x squared minus 4x squared plus 12x. So be careful with your distributing with that negative sign. So I'm going to make everything go to one side. I will have 4x squared on the right. I have to subtract 6x. That's too early. It's 1 minute too early. Then I get plus 6x, and then subtract the 18, so I get minus 18. Oops, 2. I'm going to finish this problem just so you guys know. So I solved it and I got 3/2 -3 for my 2 answers. And when I go back up and look at my original
today is Friday,
domain
April
restrictions,
30th, and we are celebrating
x cannot equal 3 and x cannot equal -3. And here I have x can equal -3. So I have to reject that.
Quick reminder before we get started for staff and students, at 9:45, all students should be accounted for in a classroom. Anyone in the hall after that should have a pass from a teacher and be moving with intention. All right, let's.
So that was the only thing we didn't have yet.
First, the hub is closed.